Well, hello everybody. Welcome to Mr. G in a Blackboard. So today we're going to go over a couple of problems to get you guys ready for your upcoming sets. I appreciate you guys' patience with me being out today because of being sick. So we're going to go ahead and jump right into it. If you want to follow along, I'm in your orange booklet doing example number 5 on page 95. Okay, so if you want to pause the video and turn to that problem, I'll give you a second to do that. So with this problem, what we're talking about is, it's first of all, it's a word problem, and we're going to get into the quadratic formula and solving quadratic equations. So here we go. So it says Pat drives 432 miles between Boston and DC in 1 hour, less than Dean, and at an average speed of 6 miles per hour faster than Dean. So when you have all these different types of relationships going on here, first of all, you don't want to introduce a whole bunch of variables. So you want to kind of minimize the variables. And I'll show you what I mean by that in a second. So first thing is I'm going to write down what's constant, right? So regardless of who's driving, it's 432 miles from Boston to DC. And then here comes the variables part. So I'm going to say let TP or T sub P equal the time Pat drives, okay, the 432 miles. And this is in hours. So you can guess that I'm going to say T sub D is the time in hours that Dean drives to get to that 432 mile mark, okay? And the relationship that they also give us is the following, that Pat's time is an hour less than Dean's time, right? So this is T sub D. So T sub P is equal to T sub D minus 1, right? So this is kind of our first relationship that they give us, right? So going back to the idea of introducing less variables if I can, I have these relationships about the times for Pat and Dean, but I also have this information that they give me about their speeds. So what I'm going to say is let R equal the rate or the speed that Dean drives. So the rate Dean drives. Okay, I'm going to say R plus 6 because they say Pat is driving 6 miles an hour faster is the rate that Pat drives. Okay, so what I want to say about this is notice that I didn't do R sub D and R sub P, right? So I'm already minimizing the number of variables I want to use by just letting R be Dean and then describing Pat's speed in terms of Dean's speed, which is what they told me anyways, right? So I kind of eliminated an extra variable there, okay? And then kind of the overarching formula that we're going to use throughout this whole problem is D equals RT. So that's distance is equal to rate times time. So here we go. So the setup I'm going to have is, again, noting that D is equal to R times T. D we already knew was 432 miles. We said that was constant. And then I'm going to describe the rest of the equation, R times T, in terms of these two setups here. T sub D minus 1, that's my time. So I'm going to describe Pat's time in terms of Dean's time. And then I'm going to use R plus 6. So describe Pat's rate in terms of Dean's rate. So if I put all that together, I have D, 432 is equal to R, which we know R plus 6 is the speed of Pat. And then the time of Pat is Dean's time, take away an hour. So this is my setup here, right? But then, oh no, I have one equation and I have two variables. So what am I supposed to do? Well, I'm going to use a relationship again that D equals RT, but we know again that D is 432. R is Dean's rate, and then T sub D is Dean's time. And then what I can do here is to eliminate this T sub D and just have R's. If I come down here, if I solve for T sub D, right, and just divide by R, now I have a substitution that I can use. This is a D here, right, to get rid of that T sub D. So my updated equation, we'll put it in a box here, is going to say 432 is equal to R plus 6 times not T sub D, but T sub D, which is equal to 432 over R minus 1. So I just made a substitution here. I used this relationship that I know about Dean, and substitute the t sub d here to get everything in terms of just r's, okay? Again, kind of having this idea of wanting to get rid of the variables or the most number of variables that I can and just keeping it as a simple problem, okay? So now what I need to do is I need to solve this equation, right? So let's get into that. So here we go. So if I have 432, right, and equal to all of this, first thing I'm going to do is I'm going to move this r that's down here and try and get it out, okay? And actually, right before I do that, I'm going to FOIL or use the box method and just multiply everything out just so I can start to work with some stuff. So if I do that, this is your result. Okay, so again, what I did there is I took this side here, I did r times 432 over r, just gives me 432. R times negative 1 is negative r. 6 times 432 over r is 2,592 over r, and then 6 times negative 1 is negative 6. So that's where all of this just came from, okay? So if you need to write down that work there, you should. And now what I'm going to do is move some things over. So I'm going to move over 432, okay? And I actually need to, no, that's good. Thought I forgot one of the signs there. So then I have negative r plus 2592 for r minus 6. Okay. And then I'm going to add r and 6 to both sides. And so the reason that I do that is because now I have kind of a more condensed version of the formula. And what I was mentioning earlier, I want to get r out of the denominator. So how I'm going to do that is multiply by r over 1 on both sides, right? Keeping in mind that I have to distribute it over here. So what I get is r squared plus 6r is equal to 2592. So what I have now is a quadratic equation. And if you remember anything about those, I need to get it equal to 0 to solve. So I'm going to subtract 2592 and have it equal to 0. So here's kind of my updated equation, if you will, that I need to solve. So typically how we do this, just like we've done in classes, I need to factor. So two numbers that multiply to negative 2,592 and add to 6. So that's kind of difficult. So I'm going to break out the handy dandy quadratic formula. So if you don't remember the quadratic formula, here it is. Okay, so looking at this problem here, my A is going to be 1. That's my leading coefficient. My B is going to be 6, and my C is going to be negative 2,592. So let's just write that down. A is 1. B is, what did we say, 6. And C is negative 2,592. Okay, so if I substitute all that in, let me just block this off a little bit. What I get is the following. X is equal to negative b, where b is 6, plus or minus the square root of 6 squared minus 4 ac, where a is 1 and c is negative 2,592, all divided by 2 times 1. Okay, and so from here, it's really just simplifying. So let's go ahead and continue this on the next page. So if I keep going with this problem, right, first thing I'm going to do is do all of this simplification here. Okay, so if I do 6 squared minus 4 times 1 times negative 2,592, what you find out that is, the negative 6 is still there, is the square root of 10,404 and then over 2 times 1, which is 2. Okay, so this problem, it would be kind of handy to have a calculator. Okay, and then the square root of 10,404 turns out to be 102. So I have two cases here. I have two answers, okay, or two answers I need to consider, a plus and a minus. So I'm going to do negative 6 plus 102 divided by 2 and negative 6 minus 102 divided by 2. So for the first case, if I do that, I get 48, and the second one I get negative 54. So in the context of the problem, though, a negative rate does not make sense. So this is going to be the R, right? Which was, if we go back to the very beginning of the problem, where do we have that at? Right there. The rate Dean drives is R. So Dean, we're going to say Dean drives 48 miles per hour. And then we already know that Pat drives 6 miles per hour faster than that, so she goes 54 miles per hour. So there's our answer for this problem. Okay, so I know there's a lot going on there. We talked about the quadratic formula. We had to set up a quadratic equation relating the relationship between two different people, and had to kind of ignore this negative case here that we got at the end. But hopefully the logic of it makes sense, and I'd encourage you to go back through and try this problem again and see if you get the same thing I did. Okay, but I'm going to keep going and continue with example 2. So example 2 is another word problem, and this can be found on page 96, problem number 7. So they say the perimeter of a rectangle is 32 inches and the area is 63 square inches. What are the dimensions of the rectangle? So first of all, let's draw a rectangle. Okay, and I'm going to let x here be the length, and then y be the width. Okay, so they tell me that the perimeter, which if I label the rest of this, hopefully remember that the perimeter, you add up all the sides. So in terms of x's and y's, x plus y, they're telling me is 32, right? In other words, 2x plus 2y equals 32. We've seen a couple problems about perimeter before. In addition to that, they say that the area, which the area of a rectangle is the length times the width, is, what they say, 63, right? So again, I have two variables floating around. Is there any way that I can kind of keep it to a minimum? And indeed there is. So what I'm going to do is I'm going to divide by y. You could also divide by x, and you'd have a different sort of writing as far as how you solve the problem, but in the end you should get the same answer that I do. So if I divide both sides by y, I have x is equal to 63 over y, and now I can substitute it in for this x. So now I don't have 2x plus 2y, I have 263 over y plus 2y equals 32, right? So I've eliminated one of the variables by substitution. And now if we multiply these out and simplify it a little bit, we get 126 over y plus 2y is equal to 32. Okay, I have, again, this kind of problem of having a y in the denominator. So just like in the last problem, I'm going to multiply by y over 1 on both sides. Okay, that's a y over 1. So I have to distribute this. So here the y's will cancel. Here I'll get a 2y squared. So I'm left with 126 plus 2y squared is equal to 32y, right? So now I have a quadratic. So like in the last problem, I need to get everything equal to 0. So I'm going to subtract 32y from both sides. So the equation that I'm solving is the following. 2y squared minus 32y plus 126 equals 0, okay? So you should be thinking about factoring in this case. So you may notice that there is a factor of 2 in common between all those terms. So I'm actually going to use that. So let me just copy the problem again here. 2y squared minus 32y plus 126 equals 0. There we go, just to have it all on one page. So I'm going to factor out a 2. Okay, and now, even though we usually keep the GCF out front there, like I did here, I definitely did that. But if I divide by 2 on both sides, I just get this, right? Because 0 divided by any number except for 0. 0 divided by 2, for example, is 0, right? So now I'm going to factor this guy and solve. So I could go back to my handy-dandy quadratic formula, but this one isn't too bad. So I want to find two numbers that multiply to 63 but add to negative 16. So that would be negative 9 and negative 7. So now what I do is I take each of those factors and I set them equal to 0. And so if I solve, here I add 7, so I get y equals 7. Here I add 9, I get y equals 9. So where is that coming from? That's actually from what's called the zero product property. So it's saying if I have this factor times this factor and they both equal 0, well, that means that one of these two things has to be 0. So I cover both cases by setting each one equal to 0, and then I solve for the variable. Okay, so you may be wondering, well, why did I get two answers for y if there's only one width? Well, if you think about a rectangle, I can have a rectangle like this, where the length is larger than the width, or I can have a rectangle like this where the width is longer than the length. So in other words, you can have two different orientations for the same rectangle, sort of, right? So to cover both cases here, if I go back to the beginning here, I know that the length is 63 divided by the width. So what that means is, in this case, I have two answers. I have, let's say that the length or the width, which is y, let's say that the width is this first answer of 9, right? Well, then our equation said that the length was 63 divided by that, so it'd be 7. And I believe this one was in inches, yep. Okay. Or let's say that the width was 7 inches, right? Well, then the length is 63 divided by that. So now the length is 9 inches, right? So both of these will give me perimeters of 32 inches, and you can go back and check, as well as an area of 63 inches squared, right? So in this case, we kind of have two different answers, which is kind of an interesting thing to think about. Okay, so these context problems, you really want to think about what do your answers mean at the end, okay? So we're going to go ahead and finish off the video with one more example. This one is not related to a word problem at all, but just another application of the quadratic formula. Okay, so example 3. 3x squared minus 2 root 5x minus 5 equals 0. So you may be wondering, why do I have a square root of 5? That's an irrational number, right? We haven't really seen anything like this. So I can go through and I can use grouping. Two numbers that multiply to negative 15 add to negative 2 root 5 and use our grouping method. Or since I know the quadratic formula, which again I'll write it here, that might be a good tool to use in this case, just because root 5s are a little bit harder to think in terms of. So negative b plus or minus square root of b squared minus 4ac all over 2a. So here my a is 3, my b is negative 2 root 5, and my c is negative 5. Okay, so let's continue this. We'll fit in a little bit of it here. So we'll have negative b, but notice that b itself is already negative. So we have a negative negative b squared minus 4ac all over 2a. Okay, so if we continue this on the next page, what I'm going to do is simplify what's known as the discriminant, the piece under the square root first. Okay, so if I do negative squared is positive, 2 squared is 4, and root 5 squared is 5. So I have positive 4 times 5, which is 20. Okay, and in addition to that, so 20, in addition to that, the negative negative 2 root 5 becomes a positive, right? Okay, and then we have minus 4 times 3 times negative 5. So that turns out to be 60. So positive 60 all over 2 times 3. Okay, sorry for switching back and forth there, but I want to make sure I get it written down right. Okay, and so we're just going to go through and simplify some of this. So 20 plus 60 is 80. Okay, I'm going to use the fact that I know that the square root of 80 is 16, is the same thing as the square root of 16 times 5. 16 times 5 is 80. Okay, so 2 root 5 plus 4 root 5. So that works out nice because I have 2 root 5s I can combine, plus or minus. Okay, so we're going to have two answers here. So we're going to have 2 root 5, let's see if I can fit this, plus 4 root 5 over 6. And looks like I'll have to fit the other one on the next page. That's okay. So let's do the plus case first. 2 root 5s plus 4 root 5s is 6 root 5s divided by 6 is just root 5. Okay, there's no context to this problem, so that is an answer I'm going to include. And then I have the negative case, which is 2 root 5 minus 4 root 5 over 6. So 2 root 5s take away 4 of them. I have negative 2 root 5s left over, and that simplifies to negative root 5 over 3. Okay, so again, this problem doesn't have a context, so there's no just ignoring what are the other answers. They just want us to straight up solve this equation that we started with here. And again, we use the quadratic formula just because we have this square root of 5, which is a little messy to work with. Definitely doable, but the quadratic formula can be helpful in that sense. Okay, so hopefully you guys found this video helpful. Go through some of the problems that I'm going to assign and put on Google Classroom. As I posted in Google Classroom, example number 2 here. Okay, example number 2 here. You need to make sure that you show me that you've written this down in your notebook somewhere to get credit for attendance for today, Tuesday, since I wasn't there. And just make sure you guys are ready for your sets. And I will see you on Thursday. Thanks for watching. Bye.